Hello viewers, welcome. So we have this question under kinematics. It says a stone thrown vertically up from the top of a tower with a velocity of 20 meters per second reaches the ground in 6 seconds. Find the height of the tower. So we are given the initial velocity and we are also given the time it will take to reach the ground, and we are looking for the height of the tower. So let's start by visualizing what this looks like. So what we have is we have a tower. So let's have our tower like that. This is our tower here. Yes, and this is the ground level. So this is the ground level here. And then we are told to say the ball is thrown vertically upwards. It implies to say it first goes up and then it comes down like that. So let's have it in that format to this point here. So it is moving in that direction. And what are we looking for? We are looking for the height of the tower. So the height of the tower is from this point here, the top, until we reach down here. So this is what we are looking for. Yes, let's call it height. So we're looking for that height, which is h height of the tower, and we're told to say the initial velocity or the beginning velocity of this stone is 20 meters per second. So let's just collect that data. So v initial is equal to 20 meters per second, and the time it takes, time, which is total time, is equal to 6 seconds. Now, what we should understand here is the time it will take to move from this point here, which is the beginning point, go up to that point and come back down up to this end point here is 6 seconds. And what we are looking for is the height of the tower, which is from this point here where the journey started from to the ground. So how do we break that down? So we're going to break it down as two different journeys. So we'll have a journey where it is starting from this up to its highest point and back to this starting point here. So we'll divide it in this format. We'll say this journey will be divided like this. Yeah. So we'll have this journey up to this initial point here. And then we'll have another journey, which is just from this point now coming down here, which is the height we are looking for. So we'll divide it in that format so that we can understand fully what is happening like that. So let's go ahead. The first step we're going to do is we're going to calculate time it will take to move from this initial point here to the top, the highest point there, before it starts coming down. So we are finding time from this beginning point up to its highest point before it starts to come down. So let's find that time, the time it will take to do that. So we're going to use V is equal to V initial added to AT. Now, in this case, we're talking about acceleration due to gravity, so we use GT. So added to GT. Our final velocity from this point, it has got an initial velocity. When it reaches the highest point before it starts coming down, its velocity there will be equal to 0. So the final velocity as it goes to its highest point there will be 0, and then it will start coming down. So this implies to say on our final velocity v here, we're going to put a 0, and this is equal to v initial is what we are given as 20, and this will be added to acceleration due to gravity. Since we are going upward in this case, we are going against gravity. It implies to say our gravity is going to be negative. So we'll have minus 9.8, and then this is multiplying by t, like that. Yes. So what we have here is 0 is equal to 20. That is subtracted by 9 minus 9.8t will just give us minus 9.8t, like that. Since we are looking for the time, we're going to take time on the other side so that it becomes positive. So we'll take this side so that it becomes positive, and this will be left there. Doing that, what we have is we're going to have 9.8t like that. 9.8t is equal to 20. And then we divide this by 9.8 to get our t value. We do the same also on the other side of the equation. When we do this, what we are going to find is our time is equal to, according to my calculator here, what I'm finding is 2.041 seconds. Yes. So this is the time it will take to reach its highest point. The highest point we are talking about is this point here, the top of the tower. On top there is thrown upward vertically. When it reaches this maximum point here, let's mark it. The time it will take to reach this point here, the maximum point here, is what we have calculated as 2.041 seconds. Now, what we should understand is the time it will take to move from this initial point up to the highest point, it will still be the same time it will take to come back to its starting point, which is the top of the tower here. So the time it takes to move from here up to the maximum point there is still the same time it will take to move up to this point of beginning here. So what this implies is it will use 2.041 seconds to go up there and also use 2.041 seconds to come back to its starting point here. So the time it will take to move from this point and back to that same point, it will be just 2 multiplied by the time we got. So we'll say that time will be, for the whole journey from the starting point back to the starting point, this is going to be equal to, so we'll have just 2 multiplied by 2.041 seconds. And when we do mathematics there, what we are getting is 4.082 seconds. So this is the time it will take to move from its initial point and back to that same point. So from this point and back to that same point up to this point here, it will take 4.082 seconds. Now, that's our first section of the question. It means we said we are dividing this into 2 sections. The first section is the journey from this point, initial point, and back to that initial point. And the second journey is now from the top of the tower until we reach the ground, which is the height we are looking for. Now, remember the time it will take from this point, go up, and then come down up to the ground is 6 seconds. Then the time it takes from this point and back to that point is 4.082 seconds. It means from the 6 seconds, we have used already 4.082 seconds. So the time remaining is the time that is going to be used to move from this point up to the ground. So let's find that time. So that time will be equal to, just say that time will be equal to t to come down, let's call it t down, will be equal to the 6 seconds we have that will be used minus, now let me get rid of this part so that we have enough space. All right. So 6 seconds minus the 4.082 seconds. So 4.082 seconds. And when you do that, we are getting a time that is 1.918 seconds. So the time we just calculated here is the time that it will take to move from the top of the tower here up to the ground. So this is the time it will take. Now we have our new information. So all we have to do is collect that new information properly. So let's do that. So time now, our new time is equal to 1.918 seconds. Our velocity initially is still 20 meters per second. And then our acceleration due to gravity, this time, acceleration due to gravity, which is g, is equal to 9.8 meters per second as a positive. Remember, we are coming down and we are taking this as a new section of the journey. So we are starting with an initial velocity of 20 meters per second, positive velocity. We are starting with our positive acceleration because we are coming down. We are following gravity. So that's 9.8. So this is now our new information. And let's go ahead to find the distance or the height of the tower. Using S, which is displacement, is equal to UT added to half. In this case, we are using G instead of A, so let's put GT squared like that. We have every information here. Our initial velocity represented by U is 20, so we'll put our 20 there. That is multiplying by our time. Our time is 1.918. And then this is being added to half of, in this case, we have 9.8 again, and it's multiplying by time, which is 1.918, but this is squared. So that's what we have. And then this will be equal to 20 multiplied by 1.918. This is giving me a 38. So 38.36. That is being added to, when you do mathematics on the other side, what we are getting is 18.03, like that. And when we do our mathematics, when we add everything here, the answer we are getting is 56.39, which is the same as 56.4 to a single decimal place. So this is now the height of the tower that we are looking for. And that's our answer for this question. So if you found this to be helpful, please subscribe to our channel, like, comment, and share with your friends.